Hello dear friends, welcome to my channel. Today's discussion is Thevenin theorem. Any linear circuit containing several voltage and resistance can be replaced by just one single voltage, okay, in series with a single resistance connected across the load. So friends, you see that here R1, R2, V1 and 0 and VAB is a current open circuit, okay. It is converted into Thevonin. How? Because you see that it is converted into Thevonin equivalent circuit. You see R is equal to Thevonin or R is equal to Thevenin or equivalent resistance of the network, and in here small e is the Thevenin open circuit, okay. Voltage is small e. Voltage small e is V1 R1 divided by R1 plus R2. So in here you have to must remember that it is linear circuit, okay, and several voltages. So Norton is different. Norton and Thevenin both are same, but they are different, okay. Their difference I will discuss when it is Norton. Then it is converted into ampere, means current, okay, current and resistance I will discuss. Now you see a linear network containing several EMF and resistance in my diagram RL, and it is converted into Thevonin. Thevonin where is RS and VS. VS is Thevenin voltage and RS is Thevenin resistance. So this is the equivalent of the Thevenin equivalent circuit of the network. Now friends, you see there is two linear two terminals. One is A, another is B, okay. Terminal A and B, and VAB is the open circuit, okay. This is the open circuit Thevenin. So linear two terminals, we have to remember we can superposition theorem which applies only to linear circuits, okay. Now again we discuss Norton's theorem states that any linear circuit is equivalent to a real current source at a selected set of terminals, okay. Linear circuit is equal to real current source, okay, at a selected set of terminals, similar to Thevenin theorem, except that the voltage source is replaced by a current source. Thevenin theorem, you see voltage source is replaced by current source. So according to the diagram, whatever you see, we see voltage source, and in the Norton you see current source, and the Norton equivalent resistance is Rn. N is equal to RIH. Norton equivalent is IN is equal to ETH divided by RTH. IH is the circuit that flows in the short circuit connected across the terminals where Norton equivalent circuit is desired. You see that Thevenin is converted into Norton. What is the Thevenin? Thevenin uses voltage. Voltage is current replaced by a current source. So friends, what is the Norton theorem? Norton theorem: complex linear electrical circuit. Electrical circuits by reducing them to single current. Okay, current source in parallel with single resistance. Okay, same factor, you see single current in here, but Thevenin it is reducing them to voltage. Okay, it is not parallel, it is, in case of Thevenin it is series. Okay, so this is the Thevenin and Norton conversion. Let's see that I will solve some problem and I will show some circuits. So this is my Norton's theorem. So friends, I give some example. Want to give some example. We see a circuit. Okay, we see, consider the linear two terminals. Okay, you see the figure. The network may contain dependent as well as independent sources. According to Thevenin theorem, network N regardless of its complexity may be replaced by the voltage source ETH. Okay, in series with a resistor RTH, assuming that the source in N are direct current. As far as external terminals A, B are connected. Okay, the resulting circuit is Thevenin equivalent circuit of N. Okay, this resultant circuit is Thevenin equivalent circuit of N, where voltage ETH is called Thevenin or open circuit. So what you will say? You say Thevenin theorem. Yeah, this is the example of Thevenin theorem. So ETH is called Thevenin or open circuit. Voltage across terminals A, B on one may perceive ETH as the voltage voltmeter reads when connected across A, B. Resistance RTH is called Thevenin or equivalent resistance of the network. RTH is called Thevenin, equivalent resistance of network. So may be calculated, RTH may be calculated as the resistance seen across A, B with all independent source in N set to 0. If however the network also contains dependent source, the procedure used is different. Terminal A, B are connected together and the short circuit current ISC flowing AB is determined. Okay, so short circuit current, so RTH is equal to ETH divided by ISC. So this formula I do not write, but you remember that RTH is equal to ETH divided by ISC. This is the short circuit current. Short circuit current. Let's move. Thevenin open circuit. Okay, I write everything whatever I have told, very briefly discussions. So now let's move Norton. So friends, let's see Norton current. You see, first is the Thevenin 30 volt is my Thevenin circuit, Thevenin circuits, uh, and it is converted into Norton circuit. Okay, in here you see that short circuit. Okay, you see that load is equal to Thevenin load is 17.5 and 30 volt is its potential. So how to get a short circuit current, ISC? Okay, short circuit current is 30 divided by 17.5, so I get 1.7 A. So I replaced it 1.7 A, and we get that RTH is 17.5, means Thevenin resistance is 17.5. So now you see Norton equivalent current circuit. Okay, Thevenin circuit is converted into Norton circuit. In my left diagram is Thevenin circuit and my right diagram is Norton. I have already Norton equivalent. Thanks for watching. I hope you can understand my whole work, and this is very interesting. Circuit analysis is very interesting. That's why I created this video, and I mentioned everything. It is the Norton equivalent and Thevenin equivalent.